All right, let's dive in. Every time you go online, you're using something you've probably heard of a million times, but maybe don't really know what it is, an IP address. Today, we're going to break down exactly what these numbers are and why they are, quite literally, the backbone of your entire digital life.
So have you ever really thought about this? When you're browsing online, how does a website from, say, halfway across the globe find its way to your specific screen? I mean, it has to bypass billions of other devices to get to you. Well, it's all thanks to your device's unique digital address. And that digital address is what we call an Internet Protocol address, or, you guessed it, an IP address. You can just think of it as a unique ID for every single device connected to a network. It's got two really critical jobs. First, it identifies your device, whether it's your laptop, your phone, your smart TV, whatever. And second, it gives it a location, so all that data knows exactly where it's supposed to end up.
Honestly, the easiest way to think about this whole thing is to compare it to a physical mailing address, right? If you want to get a package in the mail, you've got to give them your street, your city, your zip code. Well, the internet works the same way. If your device wants to receive data, like a web page or an email, it needs an IP address. That's the only way to make sure the information gets to the right digital doorstep. Okay, but this system, well, it wasn't perfect. As the internet absolutely exploded in popularity, it created this massive worldwide problem. Turns out, the original address system was just running out of room, big time.
So, the original system was called IPv4. That's the shorter one you see on the left. But, as the internet grew and grew, we desperately needed a new system, IPv6, that super long string of characters on the right. And believe me, that difference in length isn't just for show. It represents the solution to a gigantic problem.
See, that original system, IPv4, is built on what's called a 32-bit structure. Now, that just means that mathematically, it can only create about 4.3 billion unique addresses. Back in the early days of the internet, that seemed like an enormous number. I mean, who could possibly need more? But then came the explosion of computers and smartphones and smartwatches and smart fridges, and we burned through all of them way, way faster than anyone ever thought possible. We were literally facing a digital address shortage. So to solve this looming crisis, the brilliant minds behind the internet created IPv6. It uses a 128-bit structure instead of just 32-bit. Now that jump might not sound like a huge deal, but trust me, it's exponential. We went from 4.3 billion addresses to a number so massive, it's kind of hard to even wrap your head around. It's a lot. This basically gives us a near limitless supply of addresses for the foreseeable future. Just like that, the address crisis was solved.
Okay, so we have enough addresses for the whole planet and then some. Awesome. But let's bring it closer to home. How does this all work inside your house? You've got one internet connection, right? But you probably have multiple devices, laptops, phones, tablets, a game console. How on earth do they all get online at the same time?
Yeah, really think about it. Your laptop doesn't have its own internet plan, does it? Your phone doesn't either, not for Wi-Fi anyway. Of course not. They all funnel through that one single connection from your internet service provider, your ISP. So, what's the magic trick here?
Well, the answer is actually a really clever two-part system. Here's the deal. Inside your home, each one of your devices gets its very own private IP address. But to the outside world, to the rest of the internet, they all share a single public IP address. And the little box in charge of managing all this traffic? That's your router. Your router basically acts like a super efficient receptionist for your home network. It uses this process called Network Address Translation, or NAT, and it goes something like this. Let's say your laptop, with its private IP, wants to visit a website. It sends that request to the router. The router then swaps out the private IP for its single public IP and sends the request out to the internet. When the website responds, it sends the data back to that public IP. The router, being the smart receptionist it is, remembers, oh yeah, the laptop asked for this, and it forwards the data right along to your laptop's private IP. It's this seamless translation process happening constantly, thousands of times a minute.
And this whole system is so important for a few reasons. First off, it's a huge help in conserving those public IPv4 addresses we were worried about running out of. Second, it's the very reason your entire family can stream movies, play games, and work online all at the same time without a hitch. And third, and this is a big one, it adds a really nice layer of security. By hiding your device's private addresses from the public internet, it makes it much, much harder for anyone to directly target them.
Okay, so we've got public addresses and private addresses. Got it. But that leads to another question. Is your public IP address permanent. Does it just stay the same forever? Well, for most of us at home, the answer is actually no.
And that brings us to the final piece of the puzzle, the difference between static and dynamic IP addresses. A static IP is exactly what it sounds like. It's static, it's fixed, it's assigned manually, and it doesn't change. A dynamic IP, on the other hand, is temporary. It's assigned to you automatically when you connect to the network, and it can, and does, change over time.
Think of it this way, static IPs are absolutely essential for things like servers or big businesses that need a constant, reliable address. It's like having a permanent, reserved parking spot right in front of your business. They're set up manually, and yeah, they usually cost more. Dynamic IPs, though, are the standard for pretty much all of us at home. Your internet service provider just hands one out to you automatically. It's way more cost-effective for them, and honestly, it works perfectly for everyday stuff like browsing and streaming, where you just don't need a permanent address.
So how does this automatic assignment even happen? Well, when your router connects to the internet, your ISP uses a system called the Dynamic Host Configuration Protocol, or DHCP. The easiest way to picture it is that your ISP has this huge pool of available IP addresses just sitting there. DHCP simply leases one to you temporarily. That lease might last for a day, maybe a week, and when it expires, you might just get a new one from the pool. It's a super efficient system that just keeps everything running smoothly for everyone.
So the next time you hop online, just take a second to remember the incredible journey that's happening behind the scenes. From a global address crisis that was solved by a massive upgrade, to the clever, non-stop work of your little router acting as a receptionist, all the way to that temporary address your ISP just lends you for a while, your IP address isn't just some random string of numbers. It's the key that connects you to the entire digital world, and it tells a fascinating story of how data finds its way across the globe, right to you. So what story is your digital address telling right now?